Okay. Good evening, everyone. Good evening and afternoon. Let's yeah, me do the homework. Homework check karla, and then let's start with the gravitational field plus tube. Other. Mm, mm, mm. Okay. Second question. Second question is 2 to 14. Mass of the Earth is 81 times the mass of the Moon. Distance between the center of gravity of the Earth and the Moon is 4 times 10 to the power 5. We have uh, 81 times the mass of Moon, and we have a distance of 4 times 10 to the power 5 kilometers. Calculate the distance from the Earth's center of gravity where the resultant gravitational force becomes zero. It's yeah, me. Mhm. So we are talking about from Earth neither. We can take this distance as I said yesterday x. If we take this distance as simple x, we can write um gravitational force by Earth is equals to gravitational force by Moon. Gravitational force by Earth is equals to G, actually not gravitation field, gravitational acceleration. So we can write G 81m divided by h square is equals to G m divided by 4 times 10 to the power 5 minus h square. G දෙක කැපෙනවා m දෙක කපන්න පුළුවන්. We get 81 times 4 times 10 to the power 5 minus 81x. Actually, no. Minus hk squared is equals to h square. Then we can write, we can square root both sides. Then we'll get 9 times 4 times 10 to the power 5 minus 9x equals x. 9 times 4 times 10 to the power 5 is equals to 10x. X is equals to 9 times 4 is 36 times 10 to the power 4, or actually 3.6 times 10 to the power 4 kilometers. This is our final answer. Draw a rough sketch showing the variation of velocity of a spacecraft through the journey when it is launched at a velocity v. Mm-hmm. Velocity versus distance graph. Actually, yeah. Up to a point x, no, at the point x, what will happen? At the point x, what will happen? X will become 0. X will become 0. So we have the minimum position here. We have a certain velocity v here. You don't get the same velocity here, but a lower velocity, okay? Because gravitational acceleration is lower, so you actually get a lower velocity there. We can write, actually, we can draw something like this. Normally, we cannot say velocity at the center is 0, but we can say velocity at the velocity at x is minimum. 0 kilogenda back, but velocity at x is always minimum. Okay? Okay. That's our second question. Now let's go to third question. There's no doubt. Ne? If you don't have any doubts, please put a thumbs up. Thumbs up because down below. Okay. Mm, Next, a spacecraft is sent from the Earth to land on the moon. The spacecraft is sent from Earth to land on the moon. The spacecraft is launched at the Earth's surface with an acceleration of 10 ms minus 2. Then the spacecraft follows a certain trajectory and lands on the moon's surface. In order for the aircraft to land safely. ඒක අපිට වැඩක් නෑ. ඒක අර පොඩි බිල්ඩින් මිස්ටේක් එකක් තියෙන. ඒක වැඩක් නෑ. Calculate the amount of thrust that should be provided by the uh, amount of thrust that should be okay. Amount of thrust that should be provided by the engine on the surface of the Earth in order to launch. How can we tell? We have downwards gravitational acceleration. Downwards gravitational acceleration actually upwards thrust minus gravitational acceleration is equals to ma. Then we can write upwards thrust is equals to ma plus gravitational acceleration. What is our acceleration? What is the mass of the rocket? Mass of the rocket දීලා නැහැ නේද? Mass of the rocket. Mass of the rocket දුන්නේ නැහැ. Okay, mass of the rocket නැතුව කරමුකෝ. So we have m times 10 plus gravitational acceleration is gmm divided by r square. But we don't need to do this. Hey, they are given a gm over r square value. Gm over r square is what is this? This is going to be g නේද? එහෙමනම් අපිට මේම කෙලින්ම ලියන්න ඕන mg කියලා. So mg, g is also 10. So we need 20m force. 20m force to launch the spacecraft. සාමාන්‍ය m කියන්නේ how to use සාමාන්‍යයෙන් m කියන්නේ let's say m is 1000 kilograms. M is 1000 kilograms now අපිට killing me now මෙතන 20,000 newtons කියලා. But as I haven't given a value, let's just go with 20m. Okay, go everything by relative to the mass m. Calculate the thrust needed to hover on the surface of the moon. Hover on the surface of the moon කියන්නේ hover කියන්නේ we have a certain force. Either rocket එකේ තියෙනවා rocket is hovering on the surface of the moon. ඒකින්නේ the thrust provided by the rocket is equals to the thrust gravitational force of the moon. ඒ නිසා තමයි එයා hovering. So we can directly write again f minus fg is equals to 0 kila because there's no acceleration. F is equals to f, actually not earth, this is moon. Okay, f moon. F is equals to if we'll figure out g. Okay, we'll figure out gravitational acceleration of moon. We know gravitational acceleration of earth is gm over r square. Okay, actually r e square. We have to find the gravitational acceleration of moon. Gravitational acceleration of moon. Gravitational radius is given as 2 over 27. Gravitational acceleration moon. I think I forgot about the okay gravitational acceleration of moon. Mm-mm-mm. Mhm. So gravitation acceleration of moon is going to be mm, දැන් දීලා තියෙන value එකේ පොඩි අවුලක් තියෙනවා. දැන් දීලා තියෙන value එකෙත් පොඩි අවුලක් තියෙනවා. That is a test question I gave. Mm-hmm. Because actually මෙතන 227 ආවම we have 270 divided by 2 gravitation acceleration is huge value. ඒක opposite එක තමයි ඇත්තටම එන්න ඕනේ. ඒක opposite එක ආවා නම් we get a better value. That means 27 over 2. Mm-hmm. මෙතන පොඩි අවුලක් තියෙනවා. We'll leave this behind. Okay, we'll leave this question behind. Calculate the needed to loss from the surface. So මෙතන එන load මෙතන එන force එක F එකේ price එක තමයි එන්නේ. But we can say this නේ. We can say gravitational acceleration on moon is මම මේව කළා දාන්නම්. Okay, gravitational acceleration on moon is 1/6 of gravitational acceleration on earth. Okay නේ. ඒකෙන් හිටියද මේක මේ එන්න බැලුවේ but ඒක ආවේ නැහැ. Okay, කමක් නැහැ. Then we can write m times 10 divided by 6. 10 divided by 6 is equals to, let's see. So 10 divided by 6 is equals to 1.66 m theory. So let's just keep it like this. So the actual force needed to hover on the surface of the moon is 10 m divided by 6. This is the force we need to hover on the surface of the moon. If you want to launch from the surface of the moon at the same acceleration equal to the gravitational acceleration of what do you call moon, we need 2f. Here we need a force of 2f. Okay, that means 10m divided by 3. We need this force to launch from the surface of the moon. Okay, so that is our third question. Now let's do the fourth one. Radius of the Earth is 6,400 kilometers. Distance of A and B from the center of the Earth are 12,800 and 90,600 kilometers respectively. Gravitational acceleration near the Earth's surface is 10 newtons per kilogram. What is the gravitational potential energy of a body of mass 1,000 kilograms at A and at B? At A and at B. බලමුකෝ. So, yeah. What is the gravitational potential energy of the body at A? Gravitational potential energy at A. Actually, gravitational potential energy at A can be written as minus gmm over r squared. අපිට gravitational acceleration කියලා value එකක් දුන්නාද? They haven't given a value, but we can use, we have to use gravitational acceleration instead. How can we use gravitational acceleration instead? We know gravitational acceleration on the surface of the Earth is gm over r square, and this has been given a value 10 newtons per kilogram. Gravitational acceleration at a distance r from the center of the surface can be given as gm over r dash k squared. R dash k squared. So if we make this gr r dash k square, no, let's see, here no, we can substitute a certain value. What can we substitute? We can substitute the value for gm. What is gm equals to? Gm is equals to ge times r square, or in other words 10 times r square. So අපිට ලියන්න පුළුවන් gravitational acceleration of R is equals to 10 newtons per kilograms times R square divided by R dash के squared එක. Okay. Using this, we can find the gravitational acceleration of point A and point B. What is gravitational acceleration of point A? Gravitational acceleration at point A is equals to මොකක්ද? 10 times 6400 के square divided by what is the potential, what is the distance at A? 19,600, no, 12,800. 12,800 के square. This is 2 times, ne? So we can cut this and say 2. So අපිට say, we can say GA is equals to 10 divided by 4 or 2 square, to be honest. 2 square එක 4 කියලා ලියන්න පුළුවන්. 2 square එක 4 කියලා ලියන්න පුළුවන්. Then using this, we can find the gravitational acceleration, gravity potential energy at A. What is potential energy at A? Potential energy at A අපිට එනවා UA is equals to minus GM over R square එකට value එක මොකක්ද? 10 over 4 නේ. 10 over 4 times mass. What is the mass of the object? Do you have a certain mass of the object? Yes, 1000 times 1000. එතකොට මෙතනට එනවා this will give us 2.5 minus 2500 joules. Same way you can do for the for B. So we get gravitational acceleration at B is equals to මොකක්ද? 10 times 6400 square divided by 19,200 square. This is a multiple of 3. 19,200 is a multiple, 19,600 actually. 19,600 is a multiple of 3, right? Actually, it should be 19,200 there. Let's make it 19,200 and continue, I guess. 10,800, we have 6,400. When you add, you will get 18,000. 18,200. So it is 19,200. Okay. You can do it in 19,600, but it will be huge. So let's go with 19,200. So the අපිට එනවා GB is equals to 10 divided by 9 kilo. Now we can find the potential energy at point B, which is what is it? 10 over 9 කියන්නේ 10 over 9 කියන්නේ times 1000, which is going to be equals to like 1,101 kilogram, 1,101 joules. So which see, calculator එක බලන්න 10 divided by 9. Yes, 1,111 joules. Okay. So those are the potential energy at A and B. What is the minimum work that has to be done in order to move the object from A to B? Subtraction of these two will give you the answer. So for the second one, it is going to be delta work is equals to 2,500 minus 111. අපිට එනවා 9, 8, 4, 1. 1,489 joules. We need 1,489 joules of work to move it from A to B. Determine the gravitational potential difference between A and B. Gravitational potential difference හොයන්න කොහොමද? We can do two things, okay? We can do two things. Make a mass එක අඩු කරා නම් සමහරවිට එනවා. Okay, not always, but like this question ඔන්න බලන්නකො. What is the equation for gravitational potential? And we also have to do one more thing. ADC க்கு multiply பண்ணிட்டு இருக்கீங்க with a minus GMM or R. Then we have to multiply by the radius as well. So what is the radius here? Radius is 12,800 again. Multiplying by the 12,800, you don't get minus 2,500 joules. You will get you will get I forgot that. Thank you for reminding it to me. The 32 times 10 to the power 6 joules. Methane, actually, we have to multiply this by 19,200. 19,200. We are getting somewhat answer similar to 21.33 times 10 to the power 6 joules. Make a minus one, no? Okay? And that is also in kilometers. Actually, it's not 10 to the power 6, this is 10 to the power 9 because this is in kilometers. We have to turn it into meters. We have 10 to the power 3 here. So we need this much energy. So methane in meanemi methane 10.66 times 10 to the power 9 joules. Okay, ne? Unne evadama uttare. Yes, it is bit of a heavy sum. පොඩි ප්‍රශ්නයක් වුණාට it's a heavy sum, but we have to කෝණ ප්‍රශ්නයක් ආවත් ඒක හදන්නත් එපේ. ඒ නිසා තමයි we are doing it like this. Okay? Next. That is the minimum amount of work. Now they are asking for gravitational potential difference. Gravitational potential difference, if we divide by 1,000, try dividing by 1,000, you will get the same answer. Because again, you are working with minus GMM over R, but simple M is getting cancelled out. The simple M make a remove karana, I will gravitational potential again. No? So actual potential difference is actually 10.66 times 10 to the power 6. This is our potential difference. I hope you are clear with this. Okay, 1 to 5 hukum kara. I hope you all are clear with this. Thumbs up එක දාගන්න බලමු if you are clear with this. Okay. So that's it with the essay questions. Then MCQs තියෙන්නේ MCQs ටික කරමු. 8, 10, 9. We have to do 8 and 9 near the 8 and 9 කරමු. Three spheres, each of mass simple M and a capital M and radius R is kept to such that they touch each other. What is the gravitational force on them? මේමනේ සාමාන්‍ය sphere එකක් තියෙන්නේ. We keep a sphere like this. We have kept three sphere like this. The radius is R, mass is M. Now there's a story in this. If you take the centroid or the center of these spheres and connect them with each other, what do we get? We get an equilateral triangle. Okay, we get an equilateral triangle. We only need to find the force of one such object, one such sphere. The one sphere එකට හොයනකොට මේ මෙහෙවනම් හරිනේ. So we have to find the gravitational force here, here, and then cos 30 දැම්මම උත්තරේ එනවා. That is our theory. That is how we do it. So let's do it like that. First of all, what is the gravitational acceleration of one object between these two? We can write F is equals to GMM over R square. අපිට G minus masses ඔක්කොම M නිසා it's going to be M square divided by R square. So this is one force. We have two force. Actually, we have to find the upward force. We have to find මොකක්ද? There are two forces times cos 30. Cos 30 is මොකක්ද? Cos 30 is root 3 over 2. එතකොට අපිට එනවා 2 gm square divided by r square times root 3 over 2 කියලා. 2 to 2 කැපෙනවා. We are ending up with root 3 gm square divided by r square. Okay නේ? root 3 gm square divided by r square. This is our 8th question. 9th question. Two small heavy spheres, each of mass capital M, are placed at a distance r apart on a horizontal surface. The gravitational field intensity at the midpoint of the line joining the two surfaces centers of masses are. Right, දෙකක් ඉන්නවා. Distance r apart, the gravitational field intensity at midpoint. Gravitational field intensity is a vector ඒ නිසා we have to equate the forces. දැන් අපිට තියෙන්නේ එතන නම් actually they are the same masses නේ. They are same masses because they will give the same force because they are equidistant. ඒ නිසා මෙතන තියෙන resultant force එක 0. Resultant force 0 නම් gravitation acceleration එක 0. Answer is first answer. Hey, resultant force එකේ mass එක divide කරලා තමයි we are getting the gravitation acceleration. Therefore G is 0. First answer. මෙයාට fifth answer. We did 10. We also did 11. 12 එක බලමු. Which of the following statements are false? Which of the following statements are false? For a particle on the Earth's surface. Earth's surface එක දෙන්නේ Earth's surface එක rotate කරනවානේ. The linear speed is minimum at the equator. හරිද? We have a sphere. Sphere is rotating. Let's say මෙහෙම තමයි rotate වෙන්නේ. මෙහෙම rotate වෙනකොට these fingers, these knuckles of the fingers get the highest velocity නේද? මේ මෙයාගේ velocity අර නෑනේ මෙයා මැද නිකන් ඉන්නවා. මෙයා මෙහෙම turn වෙනකොට මෙයා නිකන් ඉන්නවා. මෙයාට තමයි velocity වැඩි. So same way poles have the lowest velocity and the equator has the highest velocity. So එයා වැරදි. Minimum නෙමෙයි so that is wrong. Angular speed is maximum at the equator compared to other places. Angular speed කියන්නේ මොකක්ද? The amount of angle the earth rotates during a certain period of time. It rotates 360 degrees in 24 hours. හරිද? ඒක කොහේ ගියත් එහෙමයිනේ. group එකටනේ. Give me a minute. එකනේ 2 ටාන තියෙනවා. Um, 2027 නේ. Mhm. 2027 mean with the link. කොහෙද link එක ගන්නේ? copy link. Okay, then Varun. Join in Varun. So what I was saying? Yes. Angular speed is going to be constant across the earth. The earth variety. Linear speed is minimum at the magnetic poles. It is actually zero at the magnetic poles. Magnetic poles කියන මොකද්ද? Now there is such thing in gravitational fields, okay? On the earth, even the gravity is 10 ms minus 1 everywhere on the, we have something called magnetic pole. Magnetic pole is a place in which your compass will go berserk. ඒ කියන්නේ එයා compass එකේ north එකක් දන්නේ නැහැ south එකක් දන්නේ නැහැ because the north is below the compass. Your right below the compass. Below the compass we have the මොකක්ද කියන්නේ? Yeah, magnetic poles. ඒ වගේ තැනක් කොහෙද කියලා තමයි ප්‍රශ්නේ. Okay, magnetic pole is not equal to true pole these days. Actually, reason is even though we figure out a true pole, the Earth is now tilted by an angle of around 23 degrees. 20 degrees angle එකේ තමයි එයා චුට්ටක් rotate වෙන්නේ. So that angle is caused due to the magnetic poles. Actually, the planet rotates around the magnetic pole. ඒ කියන්නේ magnet එක අරගෙන මේ turn කරනවා වගේ කතාව තමයි. The magnet has north and south poles. ඒ north and south pole axis එකේ තමයි the planet turns. That axis is actually 23.5 degrees changed from the actual true north. True north was found so long ago. I guess in 1800s or 1700s, 1700s වගේ තමයි හෙව්වේ. In 300 years, it has traveled up to 23.5 degrees. In another 300 years, it would have gone up to 50 degrees, maybe. And another 300 years, it would have gone up to 90 degrees. Now, planet can't rotate in that axis. So, yeah, මොකද කරන්නේ සාමාන්‍ය 50, 60 යනකොට it will flip. ඔන්න අර වගේ ප්‍රශ්නයක් එනවා කියලා they have figured it out. මෙයා axis වැඩි වෙලා යනවා. It won't increase at the rate that it was increasing before. Because we have cos 30 and all this, so there's a huge shift in resultant force when you shift with the same speed as earlier. Therefore, it doesn't shift that fast, but yeah, 60 වෙනකන් ගියාට පස්සේ, and it will take around 500, 600 years. It will flip. ඒ flip වෙනකොට අපි සාමාන්‍යයෙන් උඩනේ මේ northern areas summer වෙනකොට Australia වගේ areas winter වෙනවා. That dynamic will completely change. When that dynamic changes, there will be a huge shifting problem. We will maybe global warming won't be our major problem. We would have huge tsunamis and all those stuff. So yeah, so those are called magnetic poles right now. A magnetic poles we are going through linear the main thing. So actually at the linear pole, so linear magnetic poles is the axis the earth rotates with. So axis එකේ velocity එක 0 නේද? Axis එක එහෙම යනවද නෑනේ. එයාගේ velocity එක 0. If the mass and the radius of the earth are m and r respectively, the universal gravitation constant is g. Then the acceleration due to gravity at a height h from the earth's surface is. If a mass and the radius ඒකට උත්තර කිව්වේ නෑ නේද? 1 2 around. So AB around. AB around කියන්නේ fourth answer. Okay. 12th එකට fourth answer. 12th එකට fourth answer. 13th one. 13th one they are asking for the mass and the radius of the earth are m and r universal gravitation constant is g. Acceleration due to gravity at a height h. GMM over, GM over R plus H square. Make a look when a certain that is the equation. This is the fifth answer. Next, the weight of the person is 600 newtons. What is the weight of the same person on a planet with one-fifth density of one-fifth then one-fifth density and four times the radius on the lesson. Let's try. Number one, we have to find the gravitational acceleration. Why? Because for now, we have figured out 600 is equals to mg and this g is 10. Therefore, we can say 60 is equals to mass. Next, we have to find F equal gmm over r square. එහෙම කරන්න හොඳ නෑනේ. එහෙම කරන්න හොඳ නෑ. Let's discard that idea. එහෙම කරන්න හොඳ නෑ. We have to go with proportionality. So F is equals to gmm over r square. That means, okay, we have a problem now. We know m, g and r square. අවුලක් නෑ. මේ capital M දන්නේ නෑ නේද? We only know density of the band. Then we have to shift that to the density. M is equals to 0. M is equals to 0. M is equals to 0. What is our volume? 4 over 3 pi r cube. Our volume is 4 over 3 pi r cube. Density is rho. And ek dira dino. Rho ek dira dino. Actually r cube. Then we can say capital M is proportional to r cube rho kila. Are the F is proportional to actually m over r square. We don't have to think about anything else. Gravitational constant or simple m and one. We have to only think about proportionality. Oh, it is proportional to that means that is equals to by m substitute கண்டுபிடிக்கலாம் r cube rho divided by r square. ஒன்னு கெரிங்க අපිට උත්තරේ එනවා r rho කියලා. So F is proportional to r rho. Okay. Now we don't know the unknown force. But we know the radius of the planet. There is four times the radius and one-fifth the density times one-fifth the density. Method is 60. Method r is 1. R is 1. Rho is also 1. So remember them. Now we can write. Actually, we can find the answer. F is equals to මොකක්ද? F is equals to 600 divided by 5 is 120. 120 times 4 is 480 newtons. So this is our mass. Okay, this is the mass of the person standing on that planet. That is going to be, so this is going to be the second answer. On homework කරගෙන යන්නේ. For the people who join new, homework කරගෙන යන්නේ. හරි. For 15th one. 15 කරාද? If gravitational acceleration on the surface of the planet is g dash, radius of the planet is r, universal gravitational constant is g, mean density of the planet. We found m. Actually, what they have given is gravitational acceleration, right? So we can directly write g dash is equals to gm divided by r square. Yeah. Which is equals to g r cube rho divided by r square, which can get cancelled off like that. Cancel off current. They are asking for density rho. rho is equals to gr divided by g dash නේ. gr divided by g dash. ඔන්න අර වගේ උත්තරයක් තියෙන්නේ නැති වෙයි. Yes, why? මේ අපි 4 over 3 pi r cube නේ ඒක දාන්න ඕනේ. So it should be actually 4 over 3 pi r square. මෙහෙම එකක් එනවා. So මෙයා මෙතෙන්ට දානකොට we get pi 4 අන්න අර වගේ එකක් උත්තරයක් තියෙනවා. 4 pi r g dash. No, actually 4 pi r g divided by 3 g dash. Yes, that is the first answer. What is this 15th question? 16th one. Mass of the mass of the mass is mass of the mass of the mass is 0.1 times that of the earth. Mass of the mass is 4 point. What was he saying? Mass of the mass is 0.1 times that of the earth. 0.1 times that of the earth. Distance between the sun and the mass is mass is 1.5 times distance sun of earth. Sun and the earth. Ratio of gravitational force of attraction between sun and mass and divided by sun and earth. We can do this. What can we do? 16th question first of all. 16th question, what can we do is we can ask about gravitational force. Force of mass divided by force of earth is equals to gm of mass m divided by m of sun, m of mass divided by r squared is actually r of mass divided by g m of sun, m of earth divided by r of earth. Meow, capital. We are left with mass of mass is 0.1 times mass of earth divided by mass of and mass of earth. Okay. Radius of mass is 1.5 times radius of earth. Okay. මේ දෙන්න කැපෙනවා. We are left with 0.1 divided by 2.25. I guess the answer is 1 divided by 22.5. 1 divided by 22.5. Yes, that is the second answer. Second answer for 16th question. Seventeenth one කරාද? No. Figure shows an isolated system of three masses. The mass capital M is at rest under the influence of the masses M1 and M2, which are held in position indicated in the diagram. When mass M2 is doubled, capital M will remain at rest. If R2 is. හරි ඒක try එකක් දෙමු. We have that is 15, 16, 17 question. 17th one. Okay, we can erase that as well, I guess. Yeah, 17th question. We have we can say force by M1 is equals to force by M2 initially. Initially, force by M1 is gm m1 divided by 3a के squared is equals to gm m2 divided by root 2a के squared okay that is our answer no actually not root 2 2a के squared then we can simply say these two gets cancelled off m1 is m1 is equals to 9 over 4 m2 9 over 4 m2 what are we multiplying we are doubling m2 ne we are doubling m2 kamak ne in the second instance force by m1 is equals to force by 2 m2 එමන කතාව force by 2 m2 because we have doubled m2 mass force by m1 is going to be gm m1 divided by r dash के square degree because we don't know what is the value r dash के square degree actually no actually no this is going to be 3a square okay we are not changing we are not finding a new position within it we are just changing the distance which is equals to gm 2m 2 divided by r square gm get cancelled off m1 කියන්නේ 9 over 4 m2 මෙතන 2 into ඉන්නවා divided by 9a square r square 9 ට 9 කැපෙන්න පුළුවන් we are m2 ට m2 කැපෙන්න පුළුවන් we are left with r square is equals to 8 that means r is equals to root 8 no root 8 ගන්න කට්ටිය root 8 is equals to 2 root 2 so we have 2 root 2a අර 2 root 2a කියලා උත්තරයක් තියෙනවා so it is going to be our first answer for the 17th question after that what do we have I hope you understood now තේරෙනව නේද මේවා ලස්සන actually චූටි ප්‍රශ්න in A levels there are much more harder questions 20 කරා 21 21 එක yeah we did 20 next so 21 එක අපිට එනවා let's see let's try that out so number 1 we have to find the actually g කියන්නේ කෙන අපිට වැඩක් නෑ g කියන ප්‍රශ්න g කියන g කියන එක අපිට වැඩක් නෑ g is equals to what when we do this question g is equals to gmm over r square ඔන්න ඒම තියෙන ප්‍රශ්නේ හැදුවා නම් හරි okay so what are we going to do we are going to keep 17 18 21 we are going to keep g is equals to gm over r square separately here we are going to find the change in potential energy what is potential energy change in potential energy this is going to be gaining potential yeah so we can simplify the difference gmm divided by r square do we have they given certain values absolutely not okay so minus gmm divided by 2r square because they have increased the radius by r okay from the surface of the earth so අපිට කෙලින්ම එනවා gmm 3 gmm over 4r square ඔන්න එහෙම ගන්නකොට I don't think so there's an answer is there an answer There's no answer. Happy. Karpechatta parade. There is no answer there. Answer is actually 3 over 4. We can cut this over. Okay, okay. There might be an answer. I'm really sorry. There's an answer. Oh, මෙතන 2r කියලා නෙන්නේ. Then we'll get ඒක හැම වෙලේම අමතක වෙනවා. It's not squared here, so it is normal arc. මෙයා තියපදෙන් we can say answer is actually yeah GMM over 2r. GM over 2r is our answer. දැන් මෙතන GM over r squared is the gravitational accelerator. That means we can write GR is equals to GM over r කියලා නේද? අන්න දැන් මෙයාව මෙතනට දානවා. Then we get mgr divided by 2 කියලා. What is our answer then? It is our second answer. Second answer is the answer for the 21st question. 23. YouTube එක වැඩිපුර බලන්නේ YouTube එකේ ඉන්නවා කට්ටිය. YouTube එකේ වැඩිපුර Consider the following statement made regarding an object with mass m at a height h from the surface of the earth. Gravitational force acting on the object does not depend on simple h. බොරුවක්. මාර බොරුවක්. දැන් එතන GMM ආස්කර් දානකොට එතන h එක ඇඩ් කරනවා නේද? h එක ඇඩ් වෙන නිසානේ උත්තරේ එන්නේ. That is completely wrong. Gravitational, they are asking for two statements, right? Okay, they are asking for two statements. Okay. Gravitational potential does not depend on m. Potential. Yes, gravitational potential does not depend on m. That is correct. Gravitational potential energy object depends on h. ඒක දැත්තනේ. When the height increases, they are මාරු. Yes, it depends on h. So it is going to be AB is true. So BC is true. BC is true. Okay, fourth answer. 22, fourth answer. 23. Body is released from a height equal to radius of the earth. Velocity of the body when it strikes the surface of the earth will be. एक करा ने. एक ही ये करा. 23 date 24 25 26 करा. 27 करे ने. Geostationary satellite A moves in an orbit of radius r. Another geostationary satellite B with a mass twice that of A will orbit with a radius of twice that of A. Orbital path of a gravitational satellite does not depend on the mass of the satellite. Therefore, 27 එකට answer is first one. RA. We don't have to think about anything else. Escape velocity of the body projected upward is VE. If body is projected at the angle of 30 degrees with the horizontal, the escape velocity would be. ඔන්න දැන් ප්‍රශ්නේ තියෙන්නේ when we do escape velocity question, escape velocity is always measured perpendicular to the surface or perpendicular to, or parallel to the gravitational field. Yes. එතකොට දැන් මෙතන මේම 30 degrees එක ඔයා යවනවා. That means this is our escape velocity. We have to find this velocity. What is it? VE is equals to VE cos එපා. Sin 30. So V is equals to මොකද්ද? Sin 30 half නේ 2VE. So escape velocity twice එක දුන්නාම තමයි in the 30 degrees angle it will exit The Earth. The escape velocity of a body at height h from the surface of the Earth will be. Hmm. Height h of the surface of the Earth will be. Ne? R is the radius of the planet. G is the gravitational acceleration on the surface. Okay. V is the gravitational acceleration on the surface. So they act look ledak kino. Let's see. 28, 29. Ne? We'll erase this part. We'll erase this part. Um, what can we write? What can we write? First of all, we have to find the gravitational acceleration at a point h. Gravitational acceleration at the surface is equal to gm over r square. Gravitational acceleration at a point like that is given by r plus h square. Now in this, අපිට ඉච්චර කරන්න දෙයක් නෑ නේද? ඕන මෙයාව කරන්න පුළුවන්. gr square divided by r plus h square කියලා දාගන්න පුළුවන්. But this is gravitational acceleration. They are asking for potential, right? And they actually asking for escape velocity. So we have to work with energy. What is energy? What is energy here? Energy at infinity is equals to 0. Amen is it? Energy at this point h is equals to minus gmm over r square times, not times, plus half m v square. V square එකට පොඩි equation එකක් තියෙනවා නේද? What is v square equals to? V equals to actually v square equals to gr නේ. V square is equals to gr. අතනම් දන්නේ නැහැ කවුද v square is equals to gr. Nah, only nah. We are trying to find v square, so it's absolutely useless. So, energy UH is equals to U infinity. එවනේ එවනම් අපිට කෙලින් වෙන්නේ නුරා gm over r squared is equal to half v squared. ඔන්න මේ half එකත් නැති කරලා දැම්මා. 2 එක මෙතන දැම්මා. V squared is equals to r squared නෙමෙයි. How many times do I do that? Okay, කමක් නැහැ. 2gm divided by r. අපිට actually not r. It's actually r plus h. ඔන්න gm කියන කෙනාට you can write මෙයාවත් ඕනේ. gm කියන කෙනාට you can directly write because gm නේ හොයන්නේ gm කියන කෙනා you can write 2gr squared divided by r plus h. මෙයාගේ root එක තමයි velocity කියන්නේ. Do we have that answer? අපේ උත්තරේ දිනනවා thank God. So it is going to be third answer. ඔන්න මේ කතාව මෙතනට ඕනේ නැහැ. ඕකේනේ. 30. If a body is projected vertically upwards from the surface of the earth, mm, mm, body is projected vertically upwards from the surface of the earth with a velocity equal to 1/4 the escape velocity. If r is the radius, what is the maximum height obtained by the body? අපිට escape velocity equation එක දන්නවනේ. escape velocity නෙමෙයි velocity equation එක දන්නවනේ. We know the escape velocity. Now, velocity equation. What is the velocity equation equals to? V is equals to root gm divided by actually we root mhm. uh aim karne let's try the other way as well and try this way as well. Okay. Our initial no energy initially is equals to energy final. Energy initially is equals to minus gmm divided by r plus half mv square. Even again half mv square. But what is v square equals to? What is v square equals to? V square is equals to actually escape velocity is equals to 2gm r near. No, yavat mitten daakam. 2gm divided by r. Unne dekata deka kapuna, we are left with this. Is equals to minus gmm divided by r dash. gmm cancels off. We are left with math r neither. Math r actually velocity is 1/4 neither. 1/4 the escape velocity. 1/4 the escape velocity na 1/4 escape velocity make 1/4 20 by 1/4 times 1/4 times 1/4 1/16th. Then we are left with something like a resistor system plus 16r is equals to 1 over r dash. When we have balance we are getting common multiple. What do we get? 15 minus 15 plus 1. So minus 16 plus 1 is equals to 1 over r dash. Math minus r dash is equals to 16r over 15. Is this the final answer? No, they are asking for the radius from maximum height attained by the body from the surface of the earth. And මෙයාගේ r එකක් අඩු කරන්න වෙයි to find the from the surface of it. Then we'll get r over 15. මේ මෙච්චර දුරක් තමයි උඩට යන්නේ. It will only go up to r over 15. So that is our fifth answer. This is for the 30th question. 31st. Mass and the radius of the earth is m and r respectively. Escape velocity of a rocket of mass simple m on the earth's surface. Mass and the radius of the earth is m and r. Escape velocity පොඩි කතාවක් තියෙනවා. I don't know whether you may notice. Escape velocity of a rocket does not depend on the mass of the rocket. Therefore, අපි කිලින්ම ඉන්න පුළුවන් 2gm over r කියලා. So it is our 31ට 31 first answer. Escape velocity on earth is 11.2. What will the escape velocity on a planet whose mass is 1000 times and radius is 10 times that of earth? We can write 32. 32 නේද? 32 එකට escape velocity on planet on earth is equals to 11.2 and that is for 2gm over r. That is for 2gm over r. Now we have 2g 1000 m, right? It is mass is whose mass is 1000 m divided by 10r. May zeros take a kapand then we'll get 100 root of 100 is 10. So 10 2gm over r. ඕකනේ then velocity is 10 times 11.2 අපිට එන්නේ 11 112 kilometers per kilometers per second. That is the final answer. That is the first answer for 30-second question. From that, gravitational field homeworks ටික ඉවරයි. ඔව් පැයක්නේ කියලා තියෙන්නේ. Yes, gravitational field homeworks ටික ඉවරයි. Now let's do gravitational field 2. Gravitational field 2 එක අද කරමු. Do you have any doubts? Doubts තියෙනවා නම් දැන් අහන්න. Do you have any doubts? Do you have? I don't think so. නේ. Mm, okay, I don't think so. If you have no doubts, please put a thumbs up. Thumbs up එකක් දාන්න බලන්න. YouTube එක කෝ කියලා දන්නේ නැහැ. Mm, okay, now let's do the gravitational fields 2 session. To plus 2 එක බලමු. Plus 2 එකේ do the first 5 questions. First 5 questions ගන්නකො මාර ලේසි. First 5 නෙමෙයි. Yeah, first 8 ම කරමු. First 8 is trial questions. ඊට පස්සේ pass paper පටන් ගන්නවා. First 8 කරමුකෝ. It will take around 8 to 10 minutes. Neil, wish 1 to 8 में अभी कराएंगे. Questions from 1 to 8. Okay, I think that is enough time. Let's go to the questions. Okay, I'll give you a bit more time before until I raise this board. Okay, question number one. The value of acceleration due to gravity on the surface of the Earth is g. The diameter of the Earth becomes 3 times of its present value. Mass remains the same. Value of acceleration due to gravity will be. What is the equation for gravitational acceleration? Gmm over r square. Ni? Gmm over r square. Now, 3 times of its present value, it maintains value of acceleration. The radius has been increased by 9 to 3 times. So, may 3r square now. No, actually, g dash is equals to now gm over 3r ke square become. That means we get gm over 9r square. Gm over r squared is equals to g near. So g divided by 9 is our new value for gravitational acceleration. Okay, so that is going to be our third answer. Second question. Radius of a planet is r and the acceleration due to gravity on this planet is g dash. Okay. If a body of mass simple m is sent to a height of r divided by 4 from the Earth's surface, planet's actually, a planet surface, the potential energy increment will be. Potential energy increment will be. What is our initial potential energy? ఏమన్నా බලන්න. What is our initial potential energy? Initial potential, actually, potential energy difference is equals to අපිට සාමාන්‍ය මෙන්න gm over gmm over 1 over r1 plus minus 1 over r2. Can you remember this short form? Our ලොකු paragraph එකක් නැතුව. Then we have minus. Do we have g? No, gm. Hurry. What is gm equals to? Gm is equals to gr square. Neither. Gr square. R square is the radius of the planet. Radius of the planet up to its surface. Then mitten done. Okay, mass is simple, obviously. We have we have minus, isn't it? We have this value. What has happened here? They are asked that the radius is as smooth a height of r overflow from the Earth's surface. That means we have to add up the radius of the Earth as well to find the final height of the final radius of the object from the center of the Earth. Then now we can do some stuff. We can write minus gr square. When r square is one r टिके कपड़ा दान दूँ. M is equals to 4 over 5. 4 over 5 minus 5 over 5 නේද? ඉතුරු වෙන්නේ minus gr over m divided by 5. අයි මෙතන minus 1 over 5 කියලා ඉන්නේ. minus 1 over 5 times minus plus වෙනවා. grm over 5. එහෙම උත්තරයක් තියෙනවද? Yes. So that is the third answer. is the third answer. Third question. How much deep inside the Earth's crust should an object go in order for its mass to become half of the initial value? Avide mathakatha we found a equation to draw the gravitational potential versus no gravitational intensity versus radius graphic. Okay, ඇතුළට යනකොට what happened? What happened? G is proportional to R වුණා නේද? So what is our force? Force is equal to mg. Okay. Mass is not changing. G is going from G to G over 2. G over 2 වලට යන්න ඕනි නම් radius should go from R to R over 2 නේද? Then what is our answer? R over 2. Second answer. Fourth one. Two planets have radius R1 and R2. Density rho 1 and rho 2. Ratio of the acceleration due to gravity on their surface is ratio of acceleration due to gravity on the surface is ratio of acceleration. අපිට දන්නවා gravitational put හරි we wrote this equation එතකොට මෙතන එන්නේ G m over r square 4 over 3 pi r square cube rho මේ දෙක කැපිලා අපිට ඉන්නේ G actually if is equals to G 4 over 3 gm r rho. They are asking for ratio of gravitational acceleration. Gravitational acceleration is proportional to r rho කියලා ලියන්න බලන්නේ. Then what is our ratio going to be? Ratio is going to be r1 rho 1 divided by r2 rho 2. Maybe direct and I said it, I guess 1 hour ago. 1 hour, 45 minutes ago. Check කරලා බලන්න, rewind and see. Next. The next is a statement question. A spacecraft was moved from a lower circular orbit to a higher circular orbit. Which of the below quantities decreased for the spacecraft? අපේ radius එක තියෙන්නේ කොහෙද? In the denominator. Radius is at the denominator always. For energy also same. Kinetic energy also, if you substitute, you get the radius on the denominator. Angular velocity, angular velocity. For angular velocity, angular velocity also radius is below. The acceleration එකටත්, what is acceleration by the way? Centripetal acceleration. Force එකට පල්ලෙහානේ තියෙන්නේ. So when radius increases, everything will decrease. Yes, potential energy will decrease. Potential energy will increase because potential energy is equal to minus gmm over r square. Minus value එකක් අඩු වෙනවා කියන්නේ වැඩි වෙනවා කියන එක තමයි reason එක. Okay නේ? So minus value is decreasing. If you take the number line. මේ number line කියලා කතාවක් තියෙනවානේ, we did it in O levels. Let's say this is 0. Our initial gravitational acceleration is minus 200 by potential energy. ඒක minus 150 වලට ගෙනාවා. That means as it decreased, no, it has increased. So A is wrong. Okay, kinetic energy obviously decreases because velocity decreases. Angular velocity also decreases. Acceleration, yes, acceleration will decrease as well. Acceleration will decrease as well. Therefore, the answer is actually um answer for the fifth one is fourth answer. BCD decreases. BCD can decreases. A geostationary satellite is taken into another orbit. Its distance from the center of the Earth in the new orbit is 2 times that in the early orbit. Time period of revolution of the in orbit is. Can you remember our antimal derivation of the law? In that we did t squared is proportional to r cube kilo. You want to use that here? We don't know the new time. Okay, we don't know the new time, but we know the second orbit is 2 times the early orbit. So we can write 2rk cube. Initial orbit is 24 squared and within in r cube. Okay, then we can do what can we do? Um, T dash is equals to r cube to r cube capinova 8 times 24 square. As a t dash square. So if we root it, we get 8 root times 24. What is 8 root? 2 root 2 times 24. 2 root 2 can 48 root 2. 48 root 2 is that answer there? Yes. We will be spending 48 root 2 hours for the satellite to travel one revolution. So that is the fifth answer. Seventh one. Two satellites, S1 and S2, revolve around a planet in coplanar circular orbits in the same sense. The period of revolution is 1 hour and 8 hours respectively. Radius of S1 is 10 to the power 4. That means radius of S2. We take okay. I'll just do it. No need to explain how easy it is. It is going to be simply. Okay. Seventh one. T dash k square. Actually, not t dash. We know the answer. 8 square divided by 1 square is equals to r dash square divided by 10 to the power 4 square cube. Okay. Then we can say um 8 squared is 64 times 10 to the power 4 cube is equals to r cube, r dash cube. Huh. What is 64k? 64 next. 64. Mm, this is a value for 4. If you just check 4 times 4, 16, 16 times 4, 64. With the killing with 10 to the power 4 the end of round is equals to r dash. Okay, so r dash is equals to 4 times 10 to the power 4. That is the fourth answer. Okay, that is the fourth answer. That is the seventh question. Eighth question. A satellite is orbiting around the Earth at a mean radius of 4 times that of geostationary orbit. Time period of the satellite is. Time period of the satellite is. Okay, now let's do that as well. It's not that hard. So I guess we have done all the time related questions from that. So this is going to be the eighth one. T dash over 1, actually 1 square, t dash squared is equals to 4r cube divided by r cube. R gets cancelled off. We are left with t dash squared is equals to 4 times 4 times 4 is 64. Root it and we'll get something like 8. Not 8. 8. So 8 times 8, 64. So we have spent actually 8 days. Is the answer 8 days there? Yes, it is the third answer. That's it for all the trial and practice questions. Now we'll be doing past paper questions. Okay, we'll do past paper questions. So, past paper questions, let's do 9 to 13. Finish that page. 9 to 13. Let's do 9 to 13. Okay, 9 to 13. Yeah, after doing put a message as D1. D1 के दाम को ये गेम करेंगे. Okay, let's try it. Let's try this and take a break. So yeah, nice question. If V naught is the overall velocity of the satellite close to Earth, E කියලා දුන්නා. ඒ මේක තමයි කියලා දුන්නේ. හරිද? So obviously what is V naught? What is V naught? අපේ කනපට මාරුටලනේ. V naught should be on the other side. V should be on the other side. Um, Actually, as you have done it like that, we'll just say 9th එකට all දෙන්නම්. But the actual problem is, okay, V naught එකයි VE එකයි මාරු වෙලා හරිද? If we have figured this out, you will get an answer of third answer. Third answer එක එනවා. So that is the issue with the ninth question. Ninth question එක ඔන්න password බලනකොට ඒක අනිත් පැත්තට මාරු කරලා තියෙනවා. Mm, Satellite is moving in a circular orbit around the Earth. Variation of total mechanical energy E of the satellite is with the height capital H from the Earth's surface is best represented by. They are asking for total mechanical energy E of the gravitation of the satellite with height h from the surface. I don't know whether you remember, but we have an equation. We have a nice equation. That equation goes as 10th one. Um, total mechanical energy is equal to minus gmm over 2r. Now, obviously, we know with when the radius increases, it gives you a curved graph because it is in the denominator. But is it positively curved, negatively curved? Now, prashni. Actually, this is a minus GMM over R graph, ne? Where we'll get this graph, and the graph is actually given by first answer. Simple, first answer. Thereafter, so that is the answer for the 10th question. 11th one. For a satellite moving in a circular path around the Earth, the kinetic energy, gravitational potential energy, and total energy are given by K, V, and E respectively. Which of the following relationships is true? Which of the following relationship is true? E equals minus K, V equals A total energy is equals to minus of kinetic energy. Yes, so that is the first answer, obviously. It is the first answer. Second one, potential energy is not equal to minus kinetic energy. No, wrong. Third එකත් වැරදි. Fourth kinetic energy is 2 times the gravitational potential energy. That is also wrong. It is half times. It is half times the gravitational potential energy. Finally, kinetic energy is not equal to potential energy. Again, that is also wrong. 12th one. Distance between the centers of two uniform spheres M and M is R. Gravitational potential energy of these two masses are given by. This was the second question of the MCQ paper. And equation what is that? Potential energy minus GMM over R. So that is the second answer. 13th one. Assume that the Earth revolves around the Sun in a circular path of R1. Speed of V1. Mass revolves around the circular path of R2. Speed V2. What is the ratio of V1 over V2? So it is a nice thing. We are talking about V1 and R1. We can say for the 13th question, we can say gravitational force is equals to centripetal acceleration, so ma. The gravitational force we can write as gmm over r squared is equals to mv squared over r. This is what they are talking about. R can get cancelled off. We are left with m can get cancelled off. We are left with v squared is equal to gm over r. That means v1 over v2. Actually, root if you're talking about v. v1 over v2 is actually proportional to r1 over r2. Yes, it is our third answer. So third one is the answer for the 13th question. Now I'll give you a break up to now it is 4. Now it's 4 o'clock. I'll give you a break up to 4:15. Tea break ni 4:15. Okay, up to 4:15. Okay. Let's do questions 14 to 18 now. Um, 14. Suppose a spacecraft moves from Earth to Moon. Which one of the following best shows the graph that represents the variation of magnitude of its net weight and distances? Mm, give me a minute. Gravitational. Mm, 22 is 13. Yeah, so, yes, now I can remember. So the story is number one, the point where the gravitational forces become resultant of gravitational forces becomes zero is really, really, really close to the moon. Almost like 1/10 of the distance of the total distance between the moon and the earth. එහෙම තියෙනකොට first one is completely wrong. But obviously the magnitude should increase after a certain point. And also it should become almost zero at the point where it should become zero at a certain point. එහෙම තියෙන්නේ the third answer only. So the 14th one, third answer. Third one is your answer. 15. Diameter and the mean density of Jupiter are 11 times and 1/4 times that of Earth. The gravitational intensity on the Earth is 10. Gravitational intensity on the surface of the Jupiter. We can directly write. 10 equals GMM over R square. Now we are talking about Jupiter. Gravitational energy on Jupiter. We can write G 11 times the diameter. Okay. 1/4 times the mass. Actually, that is completely wrong because we are going with actually this is going to be 4 over 3 pi r cube rho. Here we are going through. So the meow kapua, we are left with that. Here also we are going to 4 over 3 pi r rho g. But the issue is our radius is 11 times. 11 times the radius, 1/4 the 1/4 is our rho value, density. And we have g. This we can easily write as 11 over 4 times 4 over 3 pi r rho g. Now, if we see 4 over 3 pi r rho g is equals to 10. So we can write 11 over 4 times 10. Um, what is 11 over 4 equals to? Okay. 11 over 4 is equals to 2.75 times 10. So we have 27.5 newtons per kilogram. This is our gravitational acceleration on the surface of Jupiter. The dimension of gravitational constants are given by කෙලිම උත්තරේ ලියන්න පුළුවන්. If not, we can find it. using some calculations. What are the calculations? We write 16 is equals to um, if equal gmm over r square. We can subject g, which will give you f r square divided by mm. Dimension of this is going to be, dimension of force is m l t minus 2. Further, this is l square. This is m square. So we are getting the final answer. Final answer. The final answer should be, what is our final answer? M minus 1 L cube T minus 2. Name M minus 1 L cube T minus 2. So this is the fifth answer. Yeah, I guess it is the here it is going to be the first answer. First answer. So why isn't this marker running? First answer. First answer. Next, 17th question. Variation of gravitational potential V due to a point mass with the distance r is represented by. Now, what is the equation of gravitational potential? First of all, V equals minus gm over r. So V is proportional to 1 over r. Actually, minus 1 over r. So our equation is, our graph is going to be something like this. This is going to be our graph. This is going to be our graph. This is potential. This is radius. Okay, next one. So that is the second answer. 18. If the ratio mass of the planet and radius of the planet for planet A is 4 times that of the mass of the planet B, give the ratio of escape velocity of A with escape velocity of B. What is escape velocity equation? Escape velocity equation is equals to 2gm over r. Now VA over VB depends on ලොකු root එකක් දාලා අපිට ලියන්න පුළුවන් MA over RA times MB over RB. හරිද? Now planet A's ratio is 4 times that of planet B's ratio. ඔන්න මෙතන ratio එකක් ලියලා තියෙන්නේ still. So we can write it is equals to root 4 කියලා. Root 4 which is equals to 2. උත්තරය තියෙනවා. Yes, that is the second answer. Okay නේ? So that is question 14 to 18. Now let's do question from 19 to 22. Question 19 to 22. Do 19 to 22. Karanda, do that. I'll give you exactly 19, 20, 21, 22. For 4 minutes. So this I'll give you like 5 to 6 minutes to try everything. 6 to 7 minutes. Okay, now let's do 19 to 22. Ah, 19. Three stars each of mass m are at the vertices of an equilateral triangle of side A, as shown in the figure. Suppose that they are the three stars rotating in circular part about the centroid, while retaining initial distances if only the mutual gravitational force are not acting on the periodic time of the system is given by. අපිට තියෙන equilateral triangle එකක්. Equilateral triangle එකක්. We have a equilateral triangle. මේකේ එක්කෙනාට force එක ඇත්තටම resultant force එක එන්නේ to the centroid by resolving the forces due to other masses. Let's first of all find the force. What is this 19 නේ? මේ force එක අපි හොයාගමු. What is this force? හරි. This force is going to be GMM, actually GM squared over A squared නේ, because the distance is A and both the masses are capital N. Okay, so we can write force is equal to GM square over A square. What is the resultant force due to it? We can say this is 60, therefore this is 30 degrees. So we can say 2f cos 30 කියලා. What is 2f cos 30? 2 times gm squared over a squared times root 3 over 2. 2 can get cancelled off. You are left with root 3 gm squared over a squared. This is our resultant force. Resultant force. But they are asking for time period. නේ? So we can write gravitational force is equals to the resultant force. Within a resultant force is equals to centripetal acceleration. Only or you can just write mr omega square. This කරදරයි r cube එකක් එනවා. Or we can do this. What is time equals to 2 pi over omega? If not 2 pi r v. අපිට v එකක් හොයාගන්න පුළුවන් නේද from time? What is time? Velocity equals to 2 pi r divided by time. I don't know whether you can see that thing. Yes, velocity is equals to 2 pi r divided by time. So ඒක මෙතන ලියනවා. Actually we get v squared over r නේ. එහෙම ලියනවා මෙතන. They ask for time period, so we can write yeah. First of all, what is the resultant force? Root 3 gm square over a square. What is the mass m? What is the velocity? 4 pi squared r square divided by t square. R කියන එක මෙතන දාගමු. Okay, actually we yeah. But the issue is, what is the radius? අර කේස් එකක් එනවනේ what is the radius කියන ප්‍රශ්නේ. The radius is, if we draw the centroid, we have to find the radius by finding the length of this one. What is the length of that? How can we find the length of that? Let's say that is r. Yeah, r කියලා කියමුකෝ. That means r is equals to, no, actually r cos 30 is equals to a divided by 2, right? R cos 30 is equals to a divided by 2. Yeah, r cos 30 is equals to a divided by 2. What is cos 30? We can write cos 30 as root 3 over 2. 2 to 2 කැපෙනවා. R is equals to a over root 3. ඔන්න මෙයා මේව තියාගම, we'll cancel it off later, okay? First of all, මෙතන r squared කැපෙන්න පුළුවන්. What else? We have t squared. T squared තිබිච්ච දැන්. Okay? And then we can cancel off m as well. Now we have subject t, okay? T එක subject කරනවා. T squared is equals to 4 pi squared. Actually, we can substitute r as 4 pi squared r. මෙතන a squared එකක් තියෙනවා, cross multiplication, and we also have root 3 gm as well. What is r? R is equals to a root 3. හරිද? So that is that. So from this we can find that time is equals to 2 pi a cube, 2 pi actually divided by 2 pi divided by root 3 3. Hari 2 pi divided by 2 pi a cube 3 gm කියලා. ඔන්න මේ වගේ උත්තරයක් තියෙනවා අර 2 pi. Yes, that is the second answer. Though it is the second answer for this question. මෙච්චර ගොඩක් ලියන්න ඕනේ අර question එකට. ලියන්න ඕනේ නැහැ, හිතන්න පුළුවන්. If you can think from here without writing this and find this correct answer, then no problem. No one will ask, how did you get that kid? ඔන්න අපිට දන්නවා මෙයාගේ a over through 3 from the mechanics lesson. If එක තියෙනවා gm squared over a squared, ඒක cos 30 කරාම root 3 gm squared over a squared එනවා. Up to this part, this මේව ඔක්කොම you can think in your mind. මේක විතරයි ලියන්න ඕනේ in a paper. Okay නේ? If you can write this completely in a paper and do it, හරි උත්තරේ එනවා. Two stars A and B of mass m1 and m2 respectively are in a circular motion due to their mutual gravitational acceleration about the point O, for which m1 r1 is equals to m2 r2. So that A or B is always collinear as shown in the figure. The radius, if the speed of m1 and m2 are v1 and v2, ratio of v1 over v2 is. Okay, 20th one, right? First of all, we have to find the ratio of v. Okay, first of all, we have we have to balance the forces near. Forces balance in netta. So we have to balance the forces first. Shall we balance it? Balance කරන්නත් ඇත්තටම ඕනේ නැහැ. Because we have to only go with I1 omega 1 equals I2 omega 2. Right? Yes, mr omega නේ. mr omega. mr squared omega. It is not that good. But let's just see, okay? Let's just see. First of all, we have to balance the gravitational force, neither. We have to balance the gravitational force. Then using that, we can find no, we don't have to do that. Okay, what is the force actually? Let's just think like that. What is the force? G m1 m2 divided by r1 plus r2 okay, squared. That is the force neither. That is the force due to gravitational wave due to because of each other. The r2 plus r1 square. That is the total distance. We can write F equals mv squared over r. And we can write two equations for this. First equation is going to be gm1 m2 divided by r1 plus r2 get squared is equals to m1 v1 squared divided by r1. Okay, v1 squared divided by r1. Method gm1 into divided by r1 plus r2 square equals to m2 v2 divided square over r2. What do we get here? M1 gets cancelled off. We get v1 squared is equals to g m2 r1 divided by r1 plus r2 के square. Method now v2 squared is equals to g actually m2 into Capinova g m1 r2 divided by r1 plus r2 square. Okay, ne? Took, then we can write what they are asking for is v1 over v2. Ne? We can write v1 squared over v2 squared. v1 squared over v2 squared. What will this give? v1 squared is gonna give us so it is gonna give us m2 r1 over m1 r1 neither. By r1 r2 these will cancel off. G and r1 plus r2 squared will get cancelled off. We are left with this. Actually this. Using the equation given, they are given m1 r1 is equals to m2 r2. We can find the ratio of r1 over r2, which is m2 over m1. Only now we can write v1 squared over v2 squared. Substituting this, we can write m2 squared over m1 squared. Square rooting this will give you v1 over v2 is equals to m1 over m2. Simple, right? Then what is our answer? Second one. Second one is our answer. That is for 20th question. #21. A particle of mass m is projected vertically upwards from a point P, which is at a distance of 2r from the center of the spherical planet, having a mass m and radius r, as shown in the figure. Escape velocity for this projectile is. Escape velocity, how do we do it? Gravitational potential energy at that point, actually then 2r is equals to VE is equals to root GM. మీరు ఉత్తరం తినది. We have one more problem, right? What is the problem? What am I missing? Yeah. Obviously, I didn't cut tar. So it is going to be R. This is our escape velocity. So that is the first answer for 21st question. 22nd, the minimum velocity v that a particle should have in order to escape from planet of mass M and radius r is. That is direct theory. Ne? Um, first one. First one. Okay. So that's it. That's it for the MCQs. Then own gravitational field prashna kavat. You can do the MCQs. Okay. Next. Uh, um, okay. Now do the 23rd question. This was, I guess, 2025 A level essay paper. 2025 A level essay paper. 2020, 23rd Karamban. Do the 23rd question. I'll give you exactly half an hour. Okay, I think time is enough. Now let's discuss the 2025 A-level paper essay question. A satellite is an artificial object placed into orbit around Earth for various purposes. Depending on their purpose and orbital characteristics, they can be classified into three main types: geostationary satellites, low Earth orbit satellites, polar orbit satellites. A. Um, yeah. Consider a satellite of mass M orbiting the Earth in a circular path with radius r from the center of the Earth. Assume that the Earth is a solid uniform sphere of mass m and the satellite is a point object. Okay. Write down an expression for gravitational force, if G, acting between the satellite and the Earth in terms of mmr and universal gravitational constant G. So we can write for 23A part 1 simply F equals GMM over R. Simple if not you will lose marks. Okay. Write down an expression for centripetal force acting on the satellite in terms of mr and v. We can write Fc is equals to mv squared over r. ඔන්න මෙයාව Fg කියලා දාගන්න. Hence derive an expression for v in terms of mr and g. අපිට ලියන්න පුළුවන් Fg is equals to Fc, therefore we can write gmm over r squared is equals to mv squared over r. M to m කැපෙනවා, r to r කැපෙනවා. We are left with v squared is equals to, actually v is equals to root gm over r. Okay නේ? Marks ගැන දැන් හිතන්න එපා. Marks with time, with paper class and all, we'll practice the marks. Okay නේ? Fourth one. Derive an expression for the orbital period t of the satellite in terms of mr and g. Derive an expression for orbital period t of in terms of mr and g. We can write simply t equals 2 pi r over v. T is equals to 2 pi r divided by, not divided by, multiplied by root r over gm. Okay, we can continue this and write 2 pi is equals to r over gm. Actually, r cube over gm. This is the equation for time period t. Derive an expression for total mechanical energy of the satellite in terms of mmr and g. Derive කියලා කියනකොට you cannot directly write the answers minus gmm over r2r. We have to derive it. How do we derive it? First of all, අපිට ලියන්න පුළුවන් total energy is equals to gravitational potential energy plus kinetic energy. What is gravitational potential energy? Minus gmm over r. Kinetic energy is equals to half mv square. Write it exactly like this. Therefore, half gmm divided by r. Now we can write total energy is equals to minus gmm over r plus half gmm over r. We are getting the final answer minus gmm divided by 2r. දැන් ඒක නිසා තමයි tut එකේ theory tut එකේ මේක ලියන්න දුන්නේ. Because if you don't know how to derive this, ඔන්න කෙලිම total energy is equals to මේක දීලා දානවා. මේකට ඒ marks එකයි ලැබෙන්නේ. You will lose 1 2 3 4 marks from here. Marks 4ක් නෑ, එකක් විතරක් ලැබෙනවා. Absolute useless නේ. Even if you don't find this, if you found this, you would have got 2 marks. Derive කරන්න දන්නවා නම් 5 marks. Derive කරන්න දන්නේ නැත්නම් actually the question says to derive it නේ. If you directly write the answer, you will actually not get marks for it. එහෙමත් දෙයක් තියෙනවා. There are some years where they clearly say If they haven't derived and they have just throw the answer, don't give marks yet. Okay? B1. What are what are three conditions that a geostationary satellite should have? What are three conditions? Number one, it should have an orbital period of 24 hours. It should have an orbital period of 24 hours, or instead of writing 24 hours, we can make it safer by writing it should have an orbital period equal to the Earth's rotational speed. Right? Actually, it's not actually 24 hours. We are running with, I guess, 24 and 1 divided by 365 times 4. The actual time period we are running with is 24 plus 1 divided by 365 times 24. Times 4. මෙයා එකතු වෙලා after 365 times after 4 years තව දවසක් හදා ගන්නවා. That's why we had a leap year. Leap year කියලා තව එකක් දාගන්නේ මෙයා නිසා තමයි. හරිද? So yeah, it is better to write equal to the rotational speed කියලා. Then you will get enough marks. Second statement, it should move in the it should move along the equator of the Earth. It should move along the equator of the Earth. Third one, it should move from මොකද්ද? We can write two ways, okay? It should lock into a position on the Earth. එමත් ලියන්න පුළුවන්. But the answer that also you'll get marks. But the marks they have given it for is it should move from west to east or the same direction as the Earth's rotation, right? The geostationary satellite, you're looking into a position. So if the Earth is rotating clockwise turn not තමයි clockwise orbit not විතරයි the geostationary satellite. Anti-clockwise move not, it won't lock into a position, it will be moving twice the speed of the Earth. Relative velocity will be twice the rotational speed of the Earth. So what? Absolutely useless, right? Why do we need to have such a unnecessary satellite? No need. That is the thing. So it must also move in the same direction, rotate with the Earth. What Second one, write down the use of geostationary satellites for telecommunication, for weather forecast, weather monitoring, for internet. Then අපි geostationary satellites පාවිච්චි කරන්නේ for internet කියලා ලියන්නත් බෑ. Because Starlink doesn't work using geostationary system. It doesn't work using geostationary system. Anyhow, satellite works something like this, okay? Hey, weather, let's talk about weather first. How do you talk about weather? Obviously, if you know how the Earth's radius is 6,400 kilometers. But the satellite orbits 36,000 kilometers away from Earth, from the Earth's surface. From 36,000 kilometers, even cos 30 degrees, sin 30 degrees looks like a huge amount. Because 36,000 kilometers divided by 2 is 18,000 kilometers. So you are going to be taking a photo of 18,000 kilometers range. 18,000 above. So what we normally do is, the geostation satellite name in Earth, this is our Earth. Okay, this is our Earth. මෙතන geostationary satellite එකක් තියෙනවා. Actually not here. Somewhere like here, මෙතන තමයි geostationary satellite තියෙන්නේ. Okay. මේව තියලා when we focus, ඔන්න මේව ලොකු photo එකක් වදිනවා. Okay. That is how we make the first photo. Second one. Okay. There's another way as well. අපි මෙයාව what we do? We only take small angles to small angle of a photo. Small angle උනාට මෙතන එනකොට it will take a huge area, okay? And then we have another satellite a bit away and then focusing to this side. So aim patch color ගන්න පුළුවන්. Okay. The only issue with this kind of geospatial satellite is you can only take the photo of one location. Number one. Number two is you cannot take or find anything related to poles. Poles කියන්නේ හරි this is the earth this is the curvature of the earth this is the pole නම් අපේ satellite එකේ තියෙන්නේ මෙතන මෙතන තියෙනකොට එයාගේ angle එක tangential yeah it won't be tangential it will be much more than the tangential angle over there. ඒතර අපිට ගොඩක් පේන්නේ from the poles therefore we use a polar orbiter. Okay නේ දැන් ඕනේ නැති දේවලු කිව්වා කමක් නැහැ. Next, a geostationary satellites need 2.1 kilowatt of continuous power for operation of its equipment. It uses solar panels with 25% efficiency and the incident um, solar intensity on the panel is 1200 watt per meter. Give me a minute. I changed my earphone. I have to check whether I can hear. Yes, yes, we can see. Okay, then it's fine. Um, okay. Um, mm, mm, mm. Mm, calculate the area of solar panel needed to generate the required power above. Power the area of solar panel needed to generate the required power above. Hurry. How can we do this? How can we do this? First of all, what is the power we need? No, first of all, can we do it? This is the third question, right? Third question. Third question, part one. We can write intensity is equals to power over area. එහෙම නේද? Then we can write power is equals to no, actually not intensity. We are finding area, so we can write power divided by intensity. What is power? And where's the equation for? Light. Light is in light is in within patangan. Light is the first place you get this equation. Then you continue using it. What is power? 2.1 kilowatts. So we can write 2100 kilowatts. Intensity is 1200 watt per meter. අපේ area එකේනවා final answer will be actually no they work with 25% efficiency, so we have to do something like this as well. We can cut this will give us 4. That means yeah, we can cut this to මේ දෙන්න කැපෙනවා මේ දෙන්නත් කැපෙනවා. We are left with 7 meter square. This is our area. This is the area of the area we should use. Output energy 2.1 times. Okay. So in certain times of the year, when Earth comes in between the sun and the satellite, sunlight will be incident onto a solar panel to a maximum period of 72 minutes per day, which is really low. In such a situation, the satellite draws electricity from rechargeable batteries to operate its equipments. Calculate the battery's output electrical energy needed to supply power in a day like this. Power in a day like this, neither. kilowatt hours are the in. So no, there's no need of a huge pressure in it. Okay. Anyhow, how it works, we have to, yeah. So output energy will be, yeah, name the current energy. Output energy will be something like, okay, we need 2100 kilowatts. This you have to get it, something like that. This will give us a value of uh, 12. Nay, we can cut it using 12. So this will be 5 and this will be 6. That has made it worse. To be honest, that has made it worse. Then let's keep it like that. 72. How else can we get? Cut current depako. We can directly find the answer like this. Actually, we can cut it like that. 6 and 5. Anyhow, you do, it will be difficult sum. Anyhow, you will get an answer of 2520 kilowatt hours. No, actually, watt hours. They're asking for kilowatt hours, so we had to write 2.52 kilowatt hours. Okay, next. The orbital radius of a low Earth orbit. Actually, this is B, okay? This is B, third question. The orbital radius of a low Earth orbit satellite is less than that of a geostationary satellite, using the expression derived in AV above. Hmm. Deduce which satellite has more total mechanical energy. Um, which satellite has more total mechanical energy? Actually, this is the gravitation satellite. Sorry, not gravity. Geostationary satellite. We'll be using geostationary satellite because the reason is um 36,000 kilometers. Yes, that is the highest form. That is the highest we have ever gone with a communication satellite. Communication or any form of other satellites. There are some other satellites we use, such as like our IS International Space Station. International Space Station. That is, I guess, going at 125,000 kilometers from Earth's surface. That is the largest project we have ever done, space project we have ever done. Um, Even decommissioning it is a huge problem right now because it's like it is currently one of the most expensive item in the world. Most of it, yes, it is the most expensive item. Actually, expensive project, not an item. Okay, even the CERN particle operator was not that expensive. Okay, compared to that, it was the most expensive project we have ever done in the world. So yeah, so decommissioning it means you have to take it somewhere else. Okay, you have to take it to a higher Earth orbit because you cannot place something else in that orbit, and it's a huge item as well. It is one of the largest space item we have ever made in the mankind have ever made. So they have problems with that. Okay, why did I tell that? Ah, yeah. So after that, the largest we have ever used, the most common space we use is geostationary satellites. Yeah, that is the highest out of those three satellites. That is the one with the highest radius. Now what they're asking, a polar satellite is a satellite that orbits the Earth in a polar orbit. It passes over the north and the south poles of the Earth in each revolution. Polar satellite orbits Earth at an altitude of 600 kilometers above the Earth's surface. Radius of Earth is 6.4 times 10 to the power 6 meters. Mass of the Earth is given. Gravitational acceleration is given as 7. Thank God. Working with 6.67 is one of the hardest things we can ever do. Pi is equals to 3. Using the expression derived in A4 above, calculate the above orbital time period of the satellite. Take pi over 3 as 1.3, root pi over 3. So let's do that. That is D1, right? D1. D1 T is equals to 2 pi R. Actually, no. 2 pi R cube divided by GM. 2 pi, 2 pi. But actually, pi is equals to 3. Pi is equals to 3. What is R cube? R cube is given as, yeah, what is R plus 4? 6,400 kilometers is what they are given as the radius of the Earth. 600 kilometers is the height from the surface. Total will give you 7,000 kilometers. So we can write 7 cube times 10 to the power 6k, 10 to the power 18 actually. Because 10 to the power 6 times, yeah, cube will give you 10 to the power 18. Divided by gravitational acceleration is, no, yeah, that is 7 times 10 to the power 11 near. 7 times 10 to the power 11. And mass is 6 times 10 to the power 6 times 10 to the power 24. This will give you a value of, we can cut these two, you'll get square. Um, we can take 7 out, right? We can take 7 out. We are 10 to the power 7 out. This is times 6. Okay. 7 times 6 times. We have 10 to the power 24, 35. 35 minus 18 is 35 minus 18 is actually it's easier like this name. 24 minus 18 is 6. That is 6, 11. So we have 6 plus 11, 10 to the power 17. We cannot work with 10 to the power 17, unfortunately. So, um, yes, we have made some kind of, yes, this is minus 11. Yes, it is minus 11. That's what I was thinking. There was some kind of error here. Okay, then you will get exactly, um, you are left with 10 divided by 6 times 10 to the power 2. We can write this again as 5 over 3 times 10 to the power 2. This will give us the final answer, 5,460 seconds, because we are working with international, standard units. Yeah, 5,460 seconds. That means it only takes a few hours. It only takes a few hours to do this. So let's see. How many revolutions per day will it complete? Give your answer to the nearest integer. We can write D2, 24 hours, 5,460. Actually, that's also wrong. Yeah, revolutions will be equals to, I guess, total time. So this is, yeah, divided by 5,460. This will give you, I guess, 16. right? Yeah, 16. So yeah, so the Earth will be running. I'm sorry. Polar satellites will turn. I mean, go through 16 rotations in a single day. Polar orbits go through 16 rotations in a single day. Then actually, what is happening? 16 is like 1.5. Okay, 24 is like 1.5 times of 16. Eh? So what is happening is these polar orbiters. Okay, every 1.5 hours will rotate. When they rotate, if you want, using the polar orbiters itself, we can find the like we can create a map of the time zones itself, time zone negative time zone. We can make a map as well. For a keynote, we use maps like we can create maps, weather forecast, and all the stuff. Explain why such a satellite can cover a large surface area of the Earth. Why? It moves from pole to pole as Earth rotates beneath it. Earth rotates perpendicular to the direction of motion. Therefore, this results in satellite passing over different longitudes on Earth each orbit. Okay? Yeah. So let's just talk about time zones instead of longitudes because time period. So like every 1.5 hour it takes a rotate, it goes through rotation. Eh? That means it can take if the angle is good enough, you can take like 2 hour slots, photos of 2 hour slots. If and it will yeah 2 hour. I mean yeah 2 hour time zones. May take photos of two time zones at the same time. එහෙම ගන්නකොට we can get a clear image of the Earth. නේද? We can get a clear image of the Earth, and it also uses less data because this is 36,000 kilometers away and it has to use a lot of its camera power just to take a single photo of the Earth. Okay, just to take a single photo of the Earth. And it has to be high quality, high pixel, yeah, really high number of pixels and all that stuff so that you can zoom. This is only going 600, just 600 kilometers above the Earth. So it doesn't need that much quality as a geostationary satellite, and it could just keep on just going through each day, going through a rotation each day and complete the task of the geostationary satellite the same amount of time. The Starlink satellite system is a collection of low Earth orbit satellites designed to provide global broadband internet coverage. As of early 2025, there were approximately 8,075 Starlink satellites orbiting the Earth at an altitude of 550 kilometers above the Earth's surface. Without doing calculations, state with regions where the Starlink satellites orbit more or less rounds the Earth per day compared to polar satellite mentioned in the above. Okay, reasoning is tell me a reason. Orbital period of the Starlink satellite is much less than that of the polar orbiter. Therefore, will rotate. I mean, yeah, will go through more revolutions or more rounds per day around the Earth than the polar satellites. Even you wanna Mars dinner. Okay. So yeah, now it's 6 o'clock. I guess we'll wind up the session for today. 24 and 25 are past paper questions. Okay, they are past paper essays. If you can do it, send me the paper. You know my number. The number is in the group. Then if you can say if you send it to me, we can I can mark and give you any advice or such to. Okay, okay then. Thank you. Goodbye.